we go with Chapter 18, Renewable Energy. First lecture on Section 1, Renewable Energy today. What we're actually using out there right now today is what we're going to talk about. So your essential question, you can identify 6 forms of renewable energy and compare their advantages, disadvantages. Something to think about as we process through there. What are they? They're all going to have advantages, disadvantages, etc. along the way. So let's take a look at what we got. All right, first off, just the definition. Energy from sources that are constantly being formed. Now, we jumped over the chapter on non-renewable energy because we're all very familiar with it. Those things that we use up quicker than the world can produce, like gasoline, coal, natural gas, etc. Uranium. Nuclear energy is very clean. It does not produce hydrocarbons, pollution, smoke, etc. But it's not renewable. Yes, the Earth is in the process of generating uranium, but we can use it up much faster than the world can produce it back. So it's not a renewable energy source. It is non-renewable. But the types of them are, once again, strongly encourage you, have PowerPoint open on one side, the lecture video up on the other. That way you can pause and look, get your notes, follow along, and get some little tips along the way that hopefully are going to help you out on the test. Well, let's look at some of these types of energy. Solar energy, obviously. The sun, it's inexhaustible, at least for the next 4 billion years. We can use all the energy the sun puts out today. Tomorrow, it puts out more. Wind energy, once again, comes back. We can't use it up faster than the world produces it. Moving water. As long as the sun is out there doing its thing, the water cycle's going to do its thing. It's going to evaporate, condense, precipitate, rain, and then we've got our moving water through streams, etc. And we can trap that moving water and move it ourselves by making dams. So we have moving water. And we have the Earth's heat, geothermal, just the lava, magma, etc. hot spots in the Earth, say like Yellowstone, which is shooting up the old faithful geyser. The water's heating up underneath the water, and then it gets hot enough to like boil, and it shoots out of the ground. We can tap into that energy. So those are 4 of the types. We'll look at some different ways we use it. The first is passive solar heating. It's the use of sunlight to heat buildings, etc. In the northern hemisphere, that's you and me, the south-facing windows receive the most solar energy. Sun rises in the east, but remember, because of the tilt of the Earth, we're at about a 23-degree tilt. That means it comes up, but it doesn't pass directly overhead. For us, it's down a little bit. If it's in the winter, it's quite low in the sky. You know, spring and fall midways, and in summer it's still not directly overhead. So if it's facing south, it comes up a little bit southeast, the sunlight hits the face of the building and it can warm the building up. We can get some free heat. So passive solar buildings tend to have large windows that face south, and an average household can reduce its energy bills by using a lot of these passive solar features. Well, my house happens to be positioned perfectly for passive solar heat, so let's head on outside and take a look at what passive solar heating actually looks like. Come on. All right, well, here is my house getting some passive solar heat. Now, my house is facing actually completely due south, and we trail up. There's the sun in the sky. It is not directly overhead because it's spring, so it's at a bit of an angle. So you can see the eaves provide some shade, and here it is right at 1 o'clock, so pretty much middle of the day. Now, in the winter time, the sun would be lower in the sky, and all of this would be getting full sunshine. But it's spring, so it's getting like half and half, partly shaded, partly in the sun. You can see the nice line there. And then I have eaves trying to protect where you walk in to keep it shaded. But this is classic over here. The eaves are designed. In the wintertime, the sun would be low and it would all be getting direct sunshine. But in the summertime, when the sun is high, the eaves up there provide deeper shadowing and it keeps it in shade. But this is just a classic example of passive solar heating. And since it's springtime, I'm getting about half and half, which, you know, pretty much what we're after. Well, there you go. A little bit of passive solar heating. You can see how my house kind of fares up. The eaves come over and that blocks the real direct sunlight in summertime when the sun's high, but when the sun's low, it misses the eaves and hits those nice big bay windows of mine and lights everything up, giving us some free heat. So some of our houses are positioned and designed specifically to take advantage of it, and others not so much. It just depends on where your house is, how it's placed, etc. But anyway, that's passive solar heating. The next one is active solar heating. Now, it's still not what you're thinking of solar energy. Active solar is where we gather solar energy, but we're only heating water. By heating the water, well, we can do some different things. We could run the water through the walls or under the ground, under the floor in your house, and therefore heat the house with this active solar energy. Of course, the most common thing we use is active solar energy just to warm our water, to take showers. When we lived in Nepal, this was how we got hot water. We didn't have electricity to provide it. We had these solar panels up on the roof, but they weren't creating electricity. Our water just snaked through it. The heat warmed it up, and then we could take a hot shower, hot bath. As you've heard me say, most of the arguments my wife and I have throughout our marriage occurred in Nepal over hot water, because you couldn't take a hot shower first thing in the morning because it'd been cold all night. You take a shower around 4 or 5 o'clock in the afternoon, not so bad. So it worked, but once again, it has its pluses, pretty much free, has its negatives. If the sun wasn't shining, you didn't have hot water, and you couldn't have hot water in the morning because it had cooled off all through the evening. But anyway, typically we mount them up on a roof, capture the sun's energy that way. Now this slide is showing you a typical one. This is exactly like what we had in Nepal. We have some of those here as well in Florida. But it's heating the water, and then what you do with the water is how we might get our fairly cheap energy. Now, I've got a little demonstration set up outside to kind of give you an idea or an example. So one more time, let's head on outdoors and take a look at what this active solar heating kind of looks like. All right, so you can see I have my hose laid out here. The hose is fairly dark, so it's been warming up. And we can come over here, and if I wind up turning my hose on a little bit, the water running out now, oh yeah, boy, that's pretty toasty. So this is an aspect of active solar heating. Now, really ideally what we would do is we would set it up there on the roof, but this is just a quick example and an idea of active solar heating. We heat the water, and then we do whatever we want with it. Take a shower or water my plants so they get nice, gentle watering. All right, see you guys back inside. As we saw out there, for me it was just my hose snaked around on the ground, but you get the idea. The sun hits it, the hose gets hot because it's kind of a black hose. The water inside the hose gets warm, and as long as I just kind of run the water slowly, it heats up as it moves through the pipe, and I get warm water. Nice, warm, gentle water to put on my plants so I don't shock the poor little guys. But if you take a look at that next slide, once again, just showing the same thing. If you do it fancy, you have a solar collector, just designed to get hotter, so the water, you run small pipes, so the water stays getting hot as long as the sun is shining. About 8% of the energy in the U.S. is used to heat water. Not much. This is something we could tap into a lot more. Once again, even if we used electricity to heat the water on after that, if we were heating water to get hot enough for a shower after it was already 75, 80 degrees, and we're only using energy to warm it, an extra 10, 15, it's a lot less energy. It's a lot cheaper than heating it from, whatever the ground temperature usually is, usually somewhere down in the 60s or very low 70s. So anyway, moving along, now we're going to get to solar energy of what you and I tend to think about. Now, interestingly enough, photovoltaic cells wasn't a vocabulary word. Probably should have been. But the my bad, I was forgetting. It is. Photovoltaic cells. This is what you and I think of as solar energy. This is where you have the solar panel out there and it's converting the sunshine into energy. Now, we're going to set these up in a virtual lab for you later, but for now, this is a basic solar panel, small scale, not the size we see up on roofs. In this case, I've got it connected up to a little motor. We'll look at some different aspects of how it works, and in just a moment, we'll pop outside and see one at work, but kind of get it in close. You can see the different cells there. Just connecting it back into wires. Now, it's not working out here because not enough energy or electricity. But if I connect it up to a LED, now I have to get the LED is sensitive to positive or negative, so it might take me a minute to get it worked out, but yep, there we go. Now, this LED takes very little energy. So even the energy coming off of my Klieg lights up there is enough to light up my little light. If I kind of unplug it, she falls off, goes off. So light, no light, all from my photoelectric cell. Once again, LED take very little power, so there's enough light in this room to trigger it up. Not enough to run this actual battery. This battery needs at least 3.5 volts, at least 3.5 ideal. It gets below 3, it won't kick on. I'm not getting enough wattage. So we'll take a look at those once again in a virtual lab, but we'll go out and take a bit as well. Let's take a look. No moving parts, so nothing running to work on it, so nothing really breaks. Once it sets out there, it's good to go. But this panel, which you can see, only puts out about the size of a typical battery if it's getting full sunlight. So we have some positives, some negatives. You're going to meet a city like Gainesville. It takes hundreds of acres of solar panels to do that, which, once again, that's a lot of space to take up with the solar panels. They're expensive to purchase right away, and obviously the negatives of if there is no sun, we get no energy. Well, let's go outside real quick, take a look at this guy in action, look at a couple of things it'll do, and if you want to see more do with it, then actually go ahead and do the virtual lab on it. Pretty cool lab. So once again, let's go ahead, head on outside, take a look at our photovoltaic cells. Hey guys, so here we are outside, beautiful sunny day, so we can look at our photovoltaic cells. These things come in all shapes and sizes. This one is produced by Shell Solar. They diversify, even though they're a energy company. So we have the individual little cells here converting sunlight into electricity. So let's kind of look at how one works. Now you get a lot of different sizes. Here's a really small one. But I've already got this one rigged up here at a decent angle to try and catch the sun. This is a multimeter. It allows us to check the wattage or voltage in something. In this case, I want to check its volts. So there we go, 3.2, 3.45, and I might be getting in the way of the sun. This thing's pulling about 3 volts. One of these bad boys is 1.5 volts. So I'm pulling about a 2 battery setup, enough to run a small toy. So let's take a look at it. So it says I got 3.5 volts. Well, let's run something. Right down here I have a little light bulb, and it'll probably be hard to see. So let's see if we can arrange it inside, so I'm going to unplug this, so it's going to go and read 0 at this point. Where's my other connector? There it is. So I'm going to connect up one side to my negative lead. One side to my positive, and I have nothing. There it is. You can see light's on. So enough to power a light, but a light's not much fun. Let's power something else. Here we go, a little toy fan, or like a propeller for an airplane. And sure enough, powers my fan just fine. So there we go. Nothing but solar panel electricity away from the sun. No power. Power. So there we go. I'm having a problem with my connections, but there we go. Solar power. No sun, no power. Sun, power. Pretty cool. Now the thing is, sure, this is big enough to run a toy, but if I want to run something like this, my whole house, well, it takes a lot more solar panels to run everything we have going in there. So anyway, real quick one with that. We will do a virtual lab with solar panels later, so if you want to do that one, sounds good. But let's take it back in and finish up this video. Obviously, solar cells take extended periods of sunshine to produce it. Typically what we do is we take that electricity and we store it in a battery, and then we can use the battery later. Or in Florida's case, typically what you do, you stick them up on your roof and we tie it directly into the grid. So while you're off at work or doing whatever, not using the electricity, it just goes into the grid for anybody to use, and they kind of give us credit. Because during the day, it's generating power, and then we get paid for the electricity our house is generating. And then later when we tap in and use the grid, it kind of goes back. So you get this net zero because we're giving to the grid and they're taking back. So basically our houses are providing electricity for businesses while we're not at home and businesses are at work, and then later when we're using it at night. Now what you can do is put up a big battery at your house. That way you can store the energy to the battery. You can use it directly during the day. It doesn't have to go to the battery. But if you use it to go store into the battery and then you draw energy off of the battery, you have energy to go through the night as long as you get enough. Obviously you get many cloudy days in a row, etc., and things go out dry and empty, no sun, no power. But currently about 1 million houses in developing countries are taking use of solar cell, and we're seeing more and more of it here in Florida, and we'll continue to see a lot more as it's getting a lot better. The next thing we're going to look at is wind power. Now wind power is actually somewhat related to the sun, because basically the sun comes out, warms up the sun. We have that radiation, remember, energy across the difference, heats up the ground. The ground warms the air right on top of it, and hot air does what? That's right, it rises. So as that warm air rises, cool air rushes in to fill it, and this cool air moving across to rise is what we know as wind. So our wind is actually caused from the sun, but we can take advantage of this different type of solar power, wind power, in a different way. So the wind comes along, once again, for us to create power. Let's go back to my little fan, and let's use this one with a propeller. So here is my engine and my motor. Now on the inside, I've got a copper coil around the magnet. So if this is spinning, then I can generate electricity, or in this case, we generate electricity and it'll allow this to spin. But all we need is a spinning turbine, copper and magnets to generate electricity. So the wind provides it for free. And here we go. So here's our nice little windmill. Now, I've got this one, I think, geared up. So in this case, let me get in close so you can see. we've got our little motor here. You can see the wires going down in. Right up under here is a LED. As we looked at before, you don't need a lot of power to run an LED. So if we spin this, if you can kind of see the motion in there. Now it's going to get loud, but here we go. And ta-da! Lights on, lights off. Lights on, lights off. As long as the wind is blowing, we get electricity because it's spinning my little turbine in here, generating electrical current, which we can see with our light. But it takes a certain amount. If I put my hair dryer on low, no light. Even though it's a LED, I have to have a certain amount of wind. I'm getting just a flicker of it there. Not enough. If I get it right in the center, I get a tiny flicker. I kick it up on high, and I get some pretty good power. All right, anyway, wind energy. The concept, fairly simple. Wind spins the turbine, just like my big guy back here. As it spins the turbine, we get free energy. All right, well, it's not free. These things are fairly expensive to build. But once they're built, their maintenance is pretty small. This is actually our fastest growing energy source in the world right now. But some of the downsides are we can't put them everywhere because once again, you need enough wind. Small amounts of wind, no power. I get high enough and you can see I can get little flickers of red. Takes a lot of wind. So large arrays of these guys we call wind farms. We've probably all seen them on a TV show, movie, documentary, something. You get a whole bunch of them out together and it's generating electricity. Here in Florida we see these solar farms. Some of our farms are now just setting up solar power instead of raising cows or growing food. They're raising energy, if you will. It's just more profitable. So, but in rural areas, some small wind farms, you may only have 20 or few coming fairly common. Once again, it doesn't take a lot of these to generate enough power for small town, etc. Big cities, it's a little different. Also, we can only carry electricity so far through wires. The electricity tends to leak out, if you will. So we have to have good conductors like copper. We insulate it with rubber or plastic around these big wires we see out there, and it's mainly to try and keep the electricity in because it slowly loses voltage along the way. So we can't put these up in Montana and get electricity for them here in Florida. So there are some limited spaces. They don't take up a lot of space though in a farm, especially if you're a cattle farm or something. Cows can eat grass all around it, even if you're raising. So some farms can put a few out there and generate electricity for themselves and even others without having to sacrifice an entire farm. We estimate that some of the windiest spots on Earth could generate 10 times the amount of power the Earth needs. Once again, the problem is getting the electricity from there all the way to here. They tried this in Nepal in this one area that in the mountains got lots of wind, but they had a problem keeping it maintained because the wind gusts were so strong, 70, 80 miles an hour, that it kept getting damaged. So a lot of wind through there could generate a lot of power, but the more wind also brings some problems with it as well. We might even be able to use these to produce hydrogen. Once again, hydrogen is a great possible energy source, but that's kind of looking to next section and these alternative energies, things that might be coming. But if we can generate the hydrogen cheaply, which is the key, hydrogen could be a non-polluting energy source. We could run our cars off of hydrogen using fuel cells, etc. So anyway, all of the large companies, GRU, even here, etc., are looking for ways to expand wind power. Currently in Florida, it's not actually windy enough. A lot of places out in the Midwest, Montana, etc., kind of like your tornado alley, they get a lot of constant wind. Here it's not quite enough. Our windmills would have to be so huge, they're just not cost effective currently. But technology is ever improving. All right, next we're going to talk about biomass fuel. Biomass, things that will burn. plants, etc., trees, shrubs, etc. Any kind of organic matter is biomass. Now we talked about in Nepal, that's what people cooked with all the time. You take corn stalks, you keep the corn, save the stalks, because you can burn them later and you're just cooking food over it. Burning something, putting your pot of rice, boiling the water, charring a piece of meat, whatever it is, just cooking with fire. We have done it for centuries. We still do it today. I go out camping. It's not unusual to just build a campfire and we cook right on the campfire. That's biomass. Nothing tricky about it. But if we use biomass in a larger scale, GRU, I'm kind of pointing this way because it's literally where it is from my house, has a biomass. So when we throw out our trees, our dirt, our leaves, etc., and GRU comes by and carries it away, we're like, yay, they took all our yard trash out. Well, they can carry that stuff to the biomass plant and burn it. They're getting free energy. We don't want the old stumps and trees. We're getting it out of our yard. GRU picks it up and they're trying to make some use out of it. They can generate energy. They also just turn it into wood chips, use it for landscaping, and create compost. All that stuff we're throwing away as somebody else's treasure, but also part of our biomass. But that's all it is. More than half of all the wood cut in the world is actually used for cooking. Remember we talked about 1,800 cubic centimeters of wood a day is the world average. You know, it's a log about the size of a 2-liter Coke. Well, in America, we're using 3 times that much wood. But in most of the world, once again, that 2-liter size bottle of Coke of wood a day is just used for cooking or heating for the most part. And although these things are a renewable resource, like trees, etc., if we relied on cutting trees down for all of our fire and energy and power, we'd be cutting the trees down, oh man, bad English. We would cut the trees down faster than they could grow. So then we would have habitat loss, deforestation, soil erosion, the whole 9 yards, desertification, etc. And also burning a lot of matter just puts pollutants up in the air. Right now in Alachua County, we're under a burn ban. We're not supposed to burn anything. This is one of the driest months, could cause fires. Also, with the COVID out there, we don't want to aggravate anybody's possible respiratory stuff, asthma, etc. So there's a burn ban. We don't want to put a lot of these pollutants into the air, even if it's simple stuff just like hydrocarbons from it. And you can also actually burn dung. Now, we're under a burn ban, so I'm not going to really do a lot, but I will show you a very simple example of what I mean by biomass and burning of cow poop. So, let's go on outside and take a look at that too. All right, here we are out here with my dog to talk about biomass. Who's a good girl? Go ahead. All right, biomass. Sticks, stuff, even Spanish moss. Basically, anything that'll burn. Nice splice logs, etc. And even cow pie, cow poop. Yep, same stuff we pulled off the farm a few days ago. I used it to help plant the blueberries. Well, this stuff will also burn. So, we lived in Nepal. This was a pretty typical fuel that people would use. So once you kind of get this stuff going, I mean, for the most part, it's really just half digested grass. So along with some of the bacteria from the cow and etc., puts a little bit of methane in. And once it gets burning, the nice thing about cow poop is it's a real nice, slow, controlled burn. So once you get this stuff going, you can see it smoking and smoldering, and it'll just give off a low smoldering heat for a long time. So it takes a little while to get it going, but once you do, it's a great fuel source, kind of like coal. You get it started and it burns long and slow for a long time. But anyway, cow poop. Also, a biomass product. So biomass, we cut the trees down, we throw them outside, and Waste Management comes by, picks it up, but they can carry it to the power plant and use it to supply power with us. A lot of the world is just cooking with us directly, but we can also use it to convert into power, electricity. Of course, the downside is, yeah, a lot of that smoke and potential pollution. And I want to try and put this out since we're under a burn ban. I don't want to really start a whole big fire and go. But anyway, thought you guys would like to see that. And we talk about burning cow dung or cow poop. That's what it looks like. All right, guys, we'll go in and finish this thing up. Take care. See you in a bit. Next slide moving in is going to talk about methane. Now, methane is very closely related to cow poop, if you will, because there is methane in cow poop, pig poop, or you go around a pig pen, it's a bad smell. Well, they're producing methane gas, just part of it. They eat their food as that organic waste is dissolved in their stomach, etc., and then they're pooping out. Well, some of that is actually methane gas. Any organic organism is producing it to a degree. Something's rotting on the side of the road, and that smell that you get, rotten smell, a lot of that is the creation of some methane. Now, we can also take trash, dump it into a biogas digester. Something specifically designed to help it rot a little quicker, creates methane. We cap it, we trap it, and we can use that methane to actually produce gas for heating and cooking. In China, more than 6 million households have biogas digesters in order for this thing in general to do. And a lot of our landfills actually generate methane as well. Some of our landfills are doing it purposely, capturing it so that we can use it for our electrical purposes. Another thing we can look at is just our old friend, alcohol. Now, this is really just isopropyl alcohol, like you can go buy at Publix, whatever. But what we do is, alcohol is, in a sense, biomass. We can take corn, etc., things of this nature, and light it on fire. It's flammable. Anything flammable we can use to generate energy, like gasoline, etc. Call those small explosions going in. So we can make this, and it's a renewable resource. We can keep growing the corn and fermenting it, or rye, or barley, etc. All of these things are used to make alcohol, plant matter. We ferment it, ta-da, alcohol. Alcohol is flammable, we can use it. In the United States right now, next time you pull up to a gas pump, take a look. It'll be 10% ethanol. This is helping to stretch our fossil fuels out because it's flammable and we just add it in. It burns, as you saw, it burns quite cleanly. Better for the environment. Of course, the downside is we have to grow it. So that's taking up space for growing, and we don't really have enough space to grow food for all of the people. So once again, all of these things have a good and they all have a downside. Clean, renewable, we can make it over and over and over, but it takes up croplands, which we need to grow food for people. So we have to look at both ways what we're doing. And most states, a lot of states require it, and all of the pumps here in Florida, next time you pull up, and it'll say right on the gas tank, 10% ethanol. Lastly, it takes us to hydroelectric power. At least I think it's lastly. It's the last one I remember. Hydroelectric, moving water. Once again, all we have to do is spin a turbine. If we spin the turbine, we generate electricity, and we can pump that out via our wires out to our households, anywhere. So hydroelectric, build a dam, water flows downhill, and we get the energy from it. Well, it's free in a sense. It's very little maintenance, and that water flows forever, and we continue to generate electricity. Tennessee Authority, they generate most of their electricity throughout Tennessee in that area, especially Knoxville, from their hydroelectric. It's relatively inexpensive to operate. They don't release any pollutants, not burning anything. The water's spinning it. Electricity itself is not a pollutant. It's how we generate it. If we're burning coal or diesel, etc., even methane, it's putting some pollutants into the air. However, if it's water spinning the turbine, we're not burning anything. So they last a lot longer than fossil fuel plants. They're not heating up as much. And they also provide some flood control. Of course, the disadvantages are it changes a river's flow, creates a lake behind it, destroying the ecosystem behind it. Also, pretty much, if we could build a dam in America, we've already done it. So there's not a lot of place for new ones to go. And it easily causes some problems for salmon fisheries because it's blocking where the salmon to get back upriver. They're having to look at some pretty creative ways to try and deal with that. Well, that's it for renewable energy today, guys. Hope you have a good rest of the day. Hit your work hard, get out there, do something, and as I say, be awesome. All right, have a good one, guys. I'm out.